To answer question 1 on the exam, I used this diagram to show my work. So the entire square, the outer square, is c squared. So this is side length is c and this side length is c. And so since c must be 5 units longer than side B, I can show that the smaller area, side B plus 5, is equal to the side of C. So then from there, I can find that this area and this area are going to be 5B, 5B, and the leftover is going to be 25. So that makes this area right here A squared, B squared, and the full one C squared. And we know this to be true because A squared plus B squared equals C squared, which is the Pythagorean theorem. And A, B, and C, the values of those would give us a Pythagorean triple. So in order to find the formula that would work to plug in for n, we first have to figure out what b is. So we take a squared, which is equal to 10b plus 25, and we solve for b. So we subtract 25, divide by 10, that gives us b is equal to a squared minus 25 over 10. So from there, we then have to plug in numbers into a to figure out what numbers work to give us a Pythagorean triple. So we try 1. 1 does not work because it will give us a negative number. So like 1 minus 25 over 10, that's just a negative number. And so we continue to try numbers until it gives us a whole positive number. So the first one that we come across that does that for this problem is 15. So we plug in 15. 15 squared is 225. We plug that into the formula. So 15 squared minus 25 over 10, that gives us 20. We add 5 to that and we get 25. And we continue to do that for all the rest of the numbers. And we find out that some numbers that work are, in addition to 15, are 25, 35, 45, and 55. And that gives us all these Pythagorean triples. So because we know this, we can then take, to find our formula, we can take 15 plus 10, and we do this because 15 plus 10 is 25, plus 10 is 35, plus 10, 45, and so on. So we know that since every number you have to add 10 to, that's going to be part of our equation. So we can plug in like 10 times 0 at first, and that gives us 15, which is a part of the Pythagorean triple. Then the next for A is 25 if you multiply 10 times 1. Multiply 10 times 2 plus the 15, that gives you 35. And so this is all the A values. So knowing this, we can take A is equal to 15 plus 10 times n minus 1 to give us our formula for A. And the reason we know that this is n minus 1 is because we have to be able to plug that 0 in. And so if n is equal to 1, we can do 1 minus 1, which will give us that 0. So simplifying this, it gives us A is equal to 10n plus 5. And knowing that this is A, we can go back to our original formula for B is equal to A squared minus 25 over 10, plug that in for A, plug that in for the A value, simplify that further, and gives us B is equal to 10n squared plus, 10n squared plus 10n. And we know that C is equal to B plus 5, so we add 5 onto that, which I forgot to do that, but it'd be 5 right there. And then for this part, so this is the chart for plugging in n is equal to 1, 5, and 10. And so for that, we are showing that this formula works. So we plug in 1, we get 15, 20, and 25 is a Pythagorean triple. When we plug in 5, we get 55, 300, 305. Plug in 10, we get 105, 1,100, and 1,105. And then, so the next part of the exam asks us to show that the blob Pythagorean theorem works for the triple when n is equal to 5. So that's why I have this one circled, because we're going to use this in the next problem. So for this blob Pythagorean theorem question, it is essentially taking the hypotenuse, saying equal to the diameter of the blob that's connected essentially to this side, Same for side A and side B. So we know that the area of a circle is pi r squared. We can take the radius, so the diameter, divided by 2 squared. Find the area of the large one is 73,061.664. And then we take, so we use the same formula for this one, find out that the area is 70,685.835. Find the area for this, the blob of A, and we find that that one is 2,375.829. So then what we can do is, because we know that a squared plus b squared must equal c squared, we add a squared plus b squared, and that gives us 73,061.664, which is the same as c squared. All right, that's all.